Let's look at this problem. I want us to, we talked about simplifying fractions. So we're going to look at multiplying and dividing, and you know how to do this. I know you do. How do you multiply fractions? Cancel them out so you don't have anything, right? You multiply straight across. Don't say cross multiply unless you want to make me upset. Of course, if you're watching this video, you can sit there at home and say cross multiply all you want to. Just know that I think very lowly of you. And at least I don't want to hear
lowly a word?
Lowly.
Lowly.
Lowly. I think very lowly of you.
It's,
okay.
I don't think it's a word.
Lowly?
Lowly?
Is it?
Yeah, it is a word.
It's a word?
Too many people
Lowly?
use it, but,
Sounds like a name.
It's like, no, you're thinking of Lola. L-O-L-A, Lola.
Okay.
Never mind. Now, I said the great thing about multiplication is the order doesn't matter, right? Have I said that at all?
No.
Maybe once only? Or have I said it a lot because it's important? That being the case, because I know some of you guys are looking at this going, well, you just cross, simplify. That's what we do. But what you need to understand is that since this is multiplication, you could rearrange this that way you're canceling right on top of each other like that. See? Uh-huh. Word. So let's look at this problem and then simplify. And that's what you do with fractions, multiply. So how can I reduce these? What's the common factor? 12. So you're saying that I could write this as what?
2/3.
12 times 2 and 12 times 3. So then the 12 is reduced like that, right?
Mm-hmm.
What about for the 55 and 25? What's their common factor? So if I write this as 5 times 11 and 5 times 5,
11 over 5.
can this 5 cross with both of these 5s?
No.
No. This 5 can only cancel with one of those, right?
Sorry. Just one.
You always cancel 1 to 1. All right, so what am I left with?
2 over
2
2
times
times
11, so that's 22 over what?
3 and 20.
15.
15.
3 times 5, which is 15, right?
Cool.
That's how you did fractions before. Notice what you had to do is you had to look at them in terms of their factors. Look at them in terms of the factors. So that means if I were to do this next problem, what could you guys do with this? X squared plus 7x plus 12 over x squared minus 9 times, oh my word, no, x squared minus 8x plus 15
It's going to be one of those long problems.
over x, oh my word, can you just stop complaining? I mean, seriously.
Saying, point out the obvious.
Yes, I am too, that you guys complain all the time. This is why you don't want to have kids, because they turn into college students. And all they do is complain. They complain and bring home their laundry for you to do. Now, you may freak out about this. I don't see this as a big problem. I see this as 4 small factoring problems. Because if I can look at this in terms of the factors, then I can cancel common factors. Well, don't raise your eyebrows like that, like, what? Get out of the city! Now look at this. If I ask you to factor this numerator, how does it factor?
X plus 4, X plus 3.
X plus 4, X plus 3. Do y'all agree?
Mm-hmm.
How about that denominator, X squared minus 9?
X plus 3, X minus 3.
It's the difference of squares, X plus 3, X minus 3. Times what?
X
So-
minus 3, X minus 5.
X minus 3 times X minus 5. In this denominator, you got to multiply, get 35, add to get the 12, so what are you going to use?
7 and 5.
So the factors are what? Don't say 7 and 5,
X
but
minus 5, X plus 7.
X minus 5, X minus 7.
Oh,
Now,
excuse me.
get out your katanas of cancellation. So we start canceling things. One on the top, one on the bottom. What can we cancel?
X plus 3.
X plus 3 right here.
X minus 5.
X minus 5.
X minus 3.
Everybody can hear your pencil. That's great. And then the X minus 3s, right? Do it again. Oh, you kidding? You need to cancel out your X minus 3s too.
We can do that?
Why?
What do you mean, why? Why can I do
Even
that?
if it's on the opposite, we can do that?
What do you mean opposite? This is multiplication. This is multiplication. It's all connected. And as we just said, the great thing about multiplication is the order doesn't matter. Look at the last example that I did up here. I said 24 times 55, 25 times 36, but then I rewrote this guy right here, and I said this. 36 times 25, was that a problem? No. So I can rearrange this, but these guys are all connected. In this numerator, all of these factors are connected through multiplication. X plus 4, X plus 3, X minus 3, and X minus 5. So as long as I have one factor in the numerator that matches with one factor in the denominator, I can cancel those guys. So now what am I left with for my
But
answer?
you're basically dividing, you're canceling, but even though it's two different.
This is multiplication. This is just one big
Okay.
fraction,
That-
right?
That makes better
So you're
sense.
left with X plus 4 or X minus 7.
X plus 4 over X minus 7, yeah. Now, were these polynomials difficult to factor?
No.
These were the nice, easy guys we've been doing a lot of. So you factor each of those guys, cancel out the common factors, and we're good to go. Questions about that?
Mm-mm.